Hello everyone. In this video, we will do some examples for finding eigenvalues and eigenvectors. Remember always, when someone gives you a matrix, ask for eigenvalues or eigenvectors, you start with the characteristic polynomial, which is determinant of a minus lambda I. Well, in this case, a minus lambda I means that you write the matrix, subtract lambda from the main diagonal. This will give me 1 minus lambda, 2 minus lambda, and then minus 1 times 1. So the characteristic polynomial is going to be so multiply these ones, it's going to be lambda squared minus 3 lambda plus 2 minus 1. Okay, I can set just that to be plus 1. Very nice. Now that we have this, eigenvalues are the roots, yes. So I said lambda squared minus 3 lambda plus 1 is equal to 0. Well, this is a quadratic equation, and it's not, actually I cannot simplify, I cannot decompose it easily, but to solve it, I can use the quadratic equation. Minus b, here is 3, plus minus root b squared minus 4ac. Divided by 2a. And if you do that, well, there are two values there. Either it is 3 plus, under the square root, I have 9 minus 4, which is just 5. And this will be 3 minus root 5 over 2. There are two eigenvalues. I found them. 3 plus root 5 over 2, or 3 minus root 5 over 2. Now, we have to go find eigenvectors. So then the next step is find eigenvectors, which is equivalent of saying find a minus lambda I times v equal to 0. Okay, so in this case, actually I can go ahead and matrix 1 is 1 minus, you can use this guy here actually for a minus lambda. So just plug in lambda there. 1 minus 3 plus root 5 over 2. This is 1 minus 2, 3 plus root 5 over 2. Then times xy must be equal to 0. Very nice. If you do simplification and all the work there you need it, you will get a minus, so 1 minus 3 over 2 is negative 1 over 2, and then I can again find the common denominator, write it like that. X plus y must be equal to 0. The other one is x plus 1 minus root 5 over 2y. You may say that, okay, what can I do with this guy? If you have done everything correctly in 2x2 case, these two equations are going to be multiple of each other. So in this case, if you multiply first equation by 1 minus root 5 over 2, you will get the second equation. So that means that you don't need to be worried about the second equation. You just try to solve the first equation or find the relation between the variable x and y. So this means that y is going to be 1 plus root 5 over 2 times x. So this means what? The second component is 1 plus root 5 over 2 times the first one. So that means that we have found all the eigenvectors. Any non-zero vector of the form, first component can be anything you like. The second component must be one this guy times the first component is an eigenvector for lambda equal to that 3 plus root 5 over 2. Well, you can put any value for x and say that that is an eigenvalue. For example, if x is equal to 2, then 2, 1 plus root 5, I did put 2 so that that 2 and 2 cancels, is an eigenvector for lambda 1. Let me call this one lambda 1. Okay. You can do similar work here for this other one. I will just go ahead and write the equations here. So it will be, let me just write everything. 1 minus, as I said, you can use this one as the coefficient matrix for your system. 1 minus 3 minus root 5 over 2. So that gives me negative 1 minus root 5 over 2, then 1, then 1, 2 minus that is a 1 plus, this must be plus root 5 over 2 times xy equals to 0. So if you write the equation forms, what you will notice that these two equations are going to be multiple of each other. In particular, the only thing you need to deal with is this guy here, and that means that y must be 1 minus root 5 over 2. I'm multiplying negative sign to this, taking that to the other side. So that means that any vector of non-zero vector, we have to be careful, eigenvector cannot be 0, of the form, the first component can be anything, the second component is a 1 minus root 5 over 2 times x, is an eigenvector for, let's say this is lambda 1, that's lambda 2. In particular, you can set again x to be 2, 1, whatever you like, but I'm putting 2 so that that will simplify a little bit that equation. Okay, that's nice. Let's do one more example here. This is a 3 by 3 matrix. I will go a little bit fast on this, but you can see all the steps here. So first thing, the characteristic polynomial. This is determinant of 2 minus lambda, negative 1 minus lambda, 3 minus lambda. Everything else you leave as they are in A. So the determinant, do it yourself, but what you will find is 2 minus lambda, negative 1 minus lambda, and 3 minus lambda. Eigenvalues, set them equal to, set this guy equal to 0. So that will give me 3 eigenvalues. It's either 2, negative 1, or 3. Since we are interested in the highest eigenvalue, the highest eigenvalue is this, and I take and try to solve, find eigenvectors. So I will try to solve this equation. 2 minus 3, 1, negative 1, 0, negative 1 minus 3, 4, 0, 0, 3 minus 3 times x, y, z. This must be equal to 0, 0, 0. And if I write this in terms of the equations, what I will get is minus x plus y minus z must be equal to 0. Then minus 4y plus 4z must be equal to 0. And then the last one is nothing. So you see that there is no condition on the third component. And just looking at the second equation, this tells me that y must be equal to z. So let me just write this one. No condition for z, but this implies that second component must be equal to the third. And if I then take that one and combine it with the first one, I get that minus x plus z minus z must be equal to 0. So that means that x must be equal to 0. So the first component must be 0, second component must be equal to the third component. So what we found, any non-zero vector of the form the first component 0, second component and third component must be equal, is an eigenvector associated or corresponding to lambda equal to 3. In particular, if z is equal to 1, we have 0, 1, 1, and eigenvalue. Eigenvector, sorry. So you see, so we start with finding eigenvalues using characteristics of polynomial. Then if we have eigenvalues, we can go ahead, solve system of equations and find eigenvectors corresponding to each one of the eigenvalues.